The first thing that we have to work on is the player movement and the player animations. That way we can at least do some basic things inside of the game. The player movement on its own is pretty simple. Since we have a character body 2D, we can simply change the velocity and then use move and slide. The velocity gets changed via the input map. I think all of this is very straightforward. For the animations, we're going to use the player move direction. But once again, since we have a ton of animations, we have to use the animation tree. Now, I am aware that for beginners, the animation tree does look a bit confusing and quite intimidating. So I will do a basic recap of it. And I guess we can get started with the actual player movement. I want to work inside of the player. And for now, inside of the animation tree, I want to get the reset state, so this looks a bit better. With the player selected, I want to attach a script. We have, by the way, I didn't talk about it, but in the file system, we have scenes, and there's characters and levels. The player is inside of characters, and this is also where I want to keep the script. That being said, the actual position doesn't matter. The defaults here are fine. We are extending a character body 2D, and fundamentally, what we want to do, we want to, for now, work on the movement, for which we will need a direction that has to be a vector 2. Other than that, I want to have var speed, which should be some kind of integer with a default value of 200. And probably a good idea to export that one. To actually do something in the game, I want to use the physics process function. We want to override the velocity, and after we have that, call move and slide, which means we have to get velocity. This one is going to set the direction of this character body 2D, which we are getting from the input map from left, right, up, and down. Those 4 directions we have to turn into a vector 2 via input.getVector. This wants to have 4 direction: negative x, negative y, and positive y, i.e. the 4 directions for the input. We have left, we have right, negative and positive x, then we have negative y, that's going to be up. Finally, we have down for positive y. This will return a normalized vector 2 that we can multiply with the speed that we have just created, and then we basically already have basic movement. And by the way, Godot is complaining here that we don't use delta, so let's add an underscore, then Godot is happy. With that set up, we can run the game scene, which, by the way, I didn't mention that, is the default thing that we are running. Inside of run, main scene is levels game. Let's run it, and then we can move the player around just fine. This works pretty well. Next up, I want this to be a bit more organized, which I am going to do via a getInput function. Only for parameters, in here, fundamentally, I first of all want to get the direction. Let me cut it out. And then override the direction variable that we have created up here. This we then want to call, before we're doing anything else, getInput. And then we can multiply velocity with the direction. Also, this shouldn't be var direction. This should just be direction. We don't want to create a new variable. We want to change the value of this one. That's all we need inside of getInput for now. Besides that, I want to set the animation. Set animation. This function doesn't exist yet, so func set animation. I guess for now we can add a pass in here and talk about the fundamental logic that we have to follow. And for that, we have to look at the animation tree. This would be the starting point. If you haven't worked inside of an animation tree, the most important thing is this output node. Whatever gets connected to it will be played as the animation. If you right-click on this field, you can add, for example, one animation. And if you click on this film reel, you can select the animations from the animation player. Let's go with sort right, connected, and then we get one sort animation. Since this animation isn't looping, Godot is only going to play it once. But if we go to move right, this is going to play forever. Oh, and by the way, this only works inside of the animation tree because the animation player has been added in here. This you have to manually attach to it. So the animation tree knows which animation player to control. This would be the easiest way to work with it, but we want to do quite a bit more. For example, for the tools, we want to toggle between a whole bunch of different ones. Where, for example, we have the animations for the hoe, for the axe, for the sword, and so on. For each of those animations, we have 4 different states that could be possible. Left, right, up, and down. Those we have to select. And this I'm doing inside of this thing, where we are toggling the animation depending on where this crosshair is. If we are, for example, on the right side, we would be getting the right animation. But I think the best way to understand that is to create it for the walk and idle state. Or in other words, if you look at the animation player, there we have 4 animations for idle. Idle down, idle left, idle right, and idle up. Those we want to work with for now. And all of those are simply 2 frames for each direction. Inside of the animation tree, first of all, I want to have a state machine for the movement. Right click on it and then add a state machine. This you want to rename to move state machine or something that you think is appropriate, and for now connect it straight to the output. This at the moment is not going to do anything because the state machine doesn't have content. For that you want to open the editor, and now we are in this field. You could add another animation, like for example idle left, and then from this start node, where you always start, you have to travel to one of the animations, which you do via this button, Connect Nodes. If you now connect the 2, we are automatically going to this idle left, and then this is what gets output, which Godot doesn't preview, but inside of the game. And for that, let me move the player a bit more into the center, like so we can see it. If I now run the game, the player is idling to the left, and that is working very well. This is exactly what we have set in here. That's a good start, but not exactly what we want. We want to dynamically select the different directions. And for that, we have another kind of workspace called a blend space. We can select a 1D or 2D one. We want to have a 2D one, which I also want to rename to idle. To that thing, we want to travel right away. On this field, you have this pencil, and in there, you are getting a blend space. The basic idea of this thing is that you have a blue marker that you can move around if you have this button selected. Besides that, you can add points to it. For example, all the way on the right, with this button selected, if you click on it, you can add an animation. For example, for idle right. And then, inside of the game, if we set this crosshair to this position, then Godot is going to select that animation. This, by the way, we want to do for all of the possible directions. I want to have a direction for left or idle left to be specific. This really has to be in the middle. So with this button selected, you can modify the points. That way you can drag them around, which you very often have to do because very often you don't hit the right point. I want to add another animation, and now you have to be careful. If you look at the axis, you can see that Y is up, which is inverted compared to the normal Godot system, where going up means decreasing Y. So the top part here is going to be idle down. Later on, we are going to use the direction to pick these points. If direction is 0 and 1, so pointing downwards, then we are on this point up here. In other words, we want to idle down. Finally, at the bottom, we have the opposite, idle up. And if you have those points, you already get something that doesn't look completely terrible. And now fundamentally, what we're doing, if I go through it step by step. This output node is the most important thing. Whatever gets attached to it will be played as the player animation. First of all, we have a state machine. That thing is the default by now, so this will always be played. Inside of the state machine, we always go to an idle state. Also the default, there's no other option at the moment. Inside of this one, we have to set this marker to one of 4 positions. Up here, to the left, down, or to the right. This we can do via the inspector. And depending on where it is, it's going to play one of these animations, whichever you have set in here. Inside of the inspector, you can double check and change this if you have made a mistake. Which means inside of the game, we now have to manage this crosshair. For that, inside of GDScript and set animation, we want to fundamentally get the animation tree and then set a blend position. If you simply type blend position in quotation marks, Godot is suggesting all of the possible ones. Now we have all of the tool state machines in here first of all. Those you can just ignore. The one that you want to look at is parameters, move state machine, idle, and blend position. It's the only one that matters for our purposes at the moment. That is then setting the marker. So instead of animation tree, via this blend position, we are setting the marker. For which we will need a vector 2, which for now can be the direction. It's not going to work perfectly, but it's going to do something. So if I now run the game, by default, we get random stuff. But if I go left, right, up, or down, we are getting the basic idle animation. Although if we stop, things break apart pretty badly. But that we can work on in the next part. Righty. It is time to fix the player character animations. At the moment, we are getting some pretty weird behavior. That happens for a couple of reasons. The most obvious one, inside of this view, where we are checking the 4 directions, we actually have to check a 5th one, the one right in the center. By default, at the moment, the blend position, so this blue marker is in this position, which by default should always be 0, just to be straightforward. From that, we get another random animation. That is because, at the moment, for this center position, Godot doesn't have any information what animation should be played, so it always defaults to some weird thing. If, however, we add an animation, let's set idle down, then this is much better. If I now run the game, we get the right default state, and if I go in the 4 directions, we are getting a much better result. That looks nice. However, now, if I go diagonally, then things get kind of weird. Once again, that is because inside of this view, we don't have the corner points. Actually, it's for 2 reasons. If I look at the code, at the moment, we are using direction. And let me print what that means. Print direction. If I run the code, we can go left, right, up, and down, and we're getting pretty clean values. It's always 0, 1, or 1 and 0, or one of those combinations. However, if I go diagonally, then we are, because of the normalized vector, getting 0.7, negative or positive 1. That means inside of the animation tree, when we're working with this blend space, we would have to target 0.7, which would be roughly somewhere here. And that, well, isn't really easy to work with. So that we have to fix in just a bit. Which means we have to cover 2 things. Number 1, we need the corner points. That part's easily fixed. Click on the top corner and then add one of the animation. This could be either idle left or idle down, depending which side you want to prefer. I'm going to go with idle left for the top and the bottom. Then on the right side, I want to have idle right for the top and the bottom, like so. And once again, make sure that all of this is nice and clean, so it looks like a reasonable result. There we go. This is much better. You can also expand it, that way it's a bit easier to work with, but generally you will need to clean up some points. With that, we have a couple of points that we can work with. Let's see how that looks inside of the game. I can go in the directions, but if I go diagonally, it still doesn't work properly. Although now at least we get different wrong animations. To fix that, inside of set animation, we have to clean up the direction. For which I want to create another variable, direction for the animation. This needs to be a vector 2 at all times. The value I want to set is going to be vector2 with x and y, where x is going to be the rounded value of direction.x. The same thing for y. Let me copy it in, except now we want to have direction.y. Once we have that, let me print what we are getting, direction animation. With that, inside of the game, I am only getting clean numbers, i.e. 0, 1, or -1 for each of the directions. This direction animation I then want to use instead of the plain direction. After that, I can run the whole thing, and now, no matter what direction I am going in, we always get the right animation. That looks pretty alright, with one exception. If I go in any direction and I stop moving, we are defaulting back to down idle. No matter where I'm going before, the player always looks down once we stop moving. That is because inside of the animation tree and the blend space, we always have this default position, but this shouldn't be the case. All we really have to do is to only run this when there is a direction, i.e. when we are moving. If direction, that's the easiest way to check if we are moving, then we want to do this. If I now run this again, I can move and I can idle in one of these 4 directions. And that is working pretty well. And I hope you get the idea here. If we are moving, so if we have a direction, then we are cleaning up the direction and we are setting the blend position inside of the animation tree. If we're doing that and then stop moving, we can still be on the right side or on the left side or wherever this cross happens to be. Even when we stop moving, since we're not updating this position anymore, we keep on playing the right animation. That gives us the first half of the player move animation, where we have the idle state. Besides that, inside of the state machine, I also want to have another blend space 2D. This one should be called move, because in there, we're going to get all of the move animations. Let me open it and simply set one animation for move down. This one. We're going to fix this in just a bit. For now, I just want to have something. To move between these two, we have to look more at this transition button. With this button selected, you have a transition button that can be set to immediate, sync, or at end. This is relative to the animation. Immediate means you're moving it, well, immediately. At end means you're moving at the end of the animation. Those are the two really important ones. Besides that, we have this auto button. If that is selected, we are traveling automatically to the next state. If it's not, we have to do it manually. In our case, we want to go from start to idle automatically. This always has to happen. But then from idle to move should be possible, but shouldn't be automatic. This we want to do in code. And this also has to go both ways. So we can go from idle to move and from move to idle. Those are the only two walking states that we want to work with. To transition between them, we once again can work inside of GDScript. Although first of all, to make this a bit easier, I want to get the move state machine inside of GDScript. For that, at the top, I want to have a section for animation and then var move state machine. The data type for this is animation node state machine playback. To get the actual value, you want to get the animation tree and get. As a string, if you simply look for playback, you can get all of the playback nodes that are available. Since we have two state machines, you either have move state machine or tool state machine. I want to have the move state machine / playback. That gives us the state machine that we actually want to control. Once we have that, basically, inside of animation, when the player is moving, we want to go to the move state. If the player is not moving, we want to be in the idle state. That is actually pretty simple. If we have a direction, we want to get the move state machine and then travel to the right state, which in this case is going to be move, or whatever you have set inside of this text box. If that is not the case, else, We want to do the same line, except now we want to travel to idle. That way, depending on direction, we are either inside of idle or move. If we try all of this, then we are getting an error. That move state machine hasn't returned anything. This is only going to return something once the scene is ready, which means we need onReady on this one. If we now try all of this again, we get the right idle animation, but once I start moving around, nothing happens. But the idle animation does work in the right direction. And I think that makes sense. Inside of the animation tree for move, we don't have anything yet. Because of that, Godot is a bit confused in terms of what it's supposed to do. That we're going to fix in the next part, and that is actually going to be your exercise. Time for an exercise. I want you to get the right walking animation for the player, so that it always looks like the player is actually walking in the right direction. This should be visible in the game right away, and you have to work in two spaces, the blend space 2D and in GDScript. Try to do this on your own and see how far you get. I'll cover it in the next part in this series. Let's finish up the player movement. For that, we want to work inside of the player and specifically the animation tree, the state machine, in which we have the move blend space. Most importantly, we have to add all of the animations. With this pen selected, add the ones that you want to add. This would, for example, be move left on the left side and move right on the right side, like so. At the top, you want to have move down, and at the bottom, you want to have move up. Then you also want the corners. In the top left, I want to have move left. Same for the bottom left, move left. Then in the top right, I want to have move right. And finally in the bottom right, move right as well. This one. Make sure all of this is nice and tidy so you actually get a proper result. Generally, for most cases, you want to have this diamond shape. With that, I can run the game, and we are not getting the walk animations. The idle animations, though, work just fine. The issue is, when we are setting the animation, at the moment, we are only updating the blend position for idle. This we also have to do for move, and then we are done. If I now run this again, I can go in all the 4 directions. I can stop. We are idling. And if I walk, we are actually walking. This works diagonally as well. And I am very happy with that. Looks perfect. I hope all of that wasn't too difficult to implement. But just to go over it really quickly, now that we have a slightly fancier system, we have the output node. And from the state machine for moving, we are creating the animation to feed it in there. Inside of that state machine, we can travel between an idle and a move state. For each of those, we are going to select the direction of the animation. That way, we are managing all of this. What is going to come next is that we are also going to work inside of the state machine for the tools. Those we are going to integrate via a one-shot node inside of the blend tree, so the main part. The way that one is going to work is we get one animation for in that plays continuously. On top of that, we can feed in another animation that we only want to play once, which in our case is going to be our tools. The output of that is then going to be the actual animation output. This state machine is going to be very similar compared to what we have already done inside of the move state machine. If I open it, you can see that we have kind of a similar system like in the move state, except now this is much more complex. By default, we're going from start to hoe. And inside of that, we have the different directions for the hoe animation. From this, we can go to any other state, X, sword, water, and fish. And we can go back to hoe. For every single animation, we can go to all of the other animations. On top of that, we can go to the end part of the animation, and this is connected to all of them. That part is important because when we are inside of the state machine for the tools, we get all of this, and these animations should only play once, which means after this animation is done, we want to go to the end state and the animation should finish. Whereas for the move state machine, both of these animations should play continuously, meaning we don't want to connect them to the end state. So basically what we have to do now is to get the state machine for the tools, travel between these different states, and then play one of the animation, depending on which one is selected. First of all, I want to get the tool state machine as a variable inside of GDScript. Tool state machine, and then this should be the tool state machine as well. These two lines are very, very similar. To use it, I want to work inside of get input. At the moment, we only check for the direction. Besides that, I want to, if input is action just pressed with action. This is a keyboard action that I have defined. It's going to be the space key on the keyboard. This one here. If that one is pressed, I want to trigger this one-shot node to play this animation once, and then return to the state machine for moving. We will need the animation tree, and then set a parameter once again. The thing that you want to look for in here is called request. That only exists for one-shot node. Parameters, one-shot, and request. This is the path that we want. This one targets this node here, on which we have a drop-down menu where we can fire, abort, and fade out. Fire plays this animation once, and abort would abort the playback of this node, if we played it during the animation. You can also fade it out, but we only really care about fire. This is what we want to do, although not by default. To get this inside of code, you can either write true in here, which does work, but isn't really the most precise data type. If you want to be super specific about it, you want to look for animation node one shot request fire. Bit of a longer line, but this is how to properly call this drop-down entry. Inside of the game, if I now use space, then the animations break completely. That happens because inside of the animation tree, inside of the tool state machine, we go from start to nothing. But we want to travel to one of these states, so this has to happen first. For now, to keep it simple, inside of the tool state machine, I want to travel to, let's say, sort. Really make sure here that you get the right names. Sort only works because I have named this part here sort. If we try this, we're going to get closer, and that is not a sort. The issue we have now is that inside of the sort, we don't have a default state in the center. We only have all of these other points around it. Now you could add a center point. Let me actually add one, and then this would work. Although in practice, we don't actually need it. Let's say the default animation for the sort is sort down right in the center. If I now run this again and I use the sort, we get the down sort animation. This would be a better start, but still not ideal. What we would rather want to do, and this has to happen inside of set animation, we also want to update the blend position for all of the tools. For example, in here, let me duplicate this line. I want to have this time the tool state machine, and I want to get the sort blend space in which we can update the blend position. The direction animation is still totally fine. And now, if I run all of this again, I can use the sort properly. That is working significantly better. This I want to do for all of the tools. Specifically, we have hoe, axe, sort, water, and fish. All of these should be updated. And to keep all of this a bit more organized, inside of the player, let's put it under the animations. I want to start using these different tool enums to organize the animations. So when you work in a team, you know that the state names are hoe, axe, sort, and so on. But another person in the team might not know that. They might call the states something like sort or sort state, or get a typo in there, and that ideally we want to avoid. One way of approaching that would be inside of the player, I want to have a const state names, for which we are going to use a dictionary where we, for example, have global.tools. Let's start with the hoe. The associated value for that is going to be hoe. This I want to duplicate a couple of times. Next up we have X, then we have water, we have sort, and finally we have fish. The animation names for that are X, water, sort, fish. Once again, these names have to match up with these names inside of the AnimationTree state machine. Generally, you want to rely on enums to keep everything organized. Cool. Once we have that, inside of set animation, we can use a for loop. For state in, and then I want to get this dictionary. Let me copy it. And for now, I only care about the values. Inside of the for loop then, I want to get rid of the sort and instead insert a string into here with the state. That way we get parameters to state machine, after which we get to, for example, to O, and in there we're getting the blend position, which we are then updating via direction animation. Let's try that one. I can now walk around. The sort is still working just fine, so this is pretty neat. The last quick thing for now that I want to implement is that when we are using a tool, the player should stop moving for a short amount of time, for which I want to add another variable, can_move. This should be a boolean that by default is true. And then when we are getting input from the player inside of this if statement, can_move should be false. On top of that, to actually use can_move inside of physics process, I only want to get input if we can move, meaning if can_move then get input. And on top of that, to make sure that velocity doesn't do anything, I want to also multiply it with the integer value of can_move. Since can_move is a boolean, if we're turning it into an integer, true will become 1 and false will become 0, which for the full line means if this value is true, these two values are not going to change. If it is false, the entire thing is going to be 0. That way, if I use the sort once, the player cannot move anymore, and that is doing at least something. Afterwards though, we want to go back to moving, which we can get via the AnimationTree signals. If you look at Node, there we have animation finished. And at this point, do be careful. If you have an animation player inside of the AnimationTree, the animation player signals aren't working reliably anymore. You want to primarily use the AnimationTree signals. In there, animation finished, connected to the player. This is fine. All we want to do in here is can_move, should be true again. We also get the animation name, but we don't really care about that. I can run around. The player is static while we have the animation, and afterwards we are going back to moving around. That is working pretty well. And on top of that, I can also try different states besides sort. Let's try fish. That is looking pretty solid. And for one more test, let's go with X. That is also working quite nicely.